Today, people everywhere benefit from the tremendous pace of technological advancement. Scientists and engineers are devoting their careers to improving our quality of life and that of the environment. Yet one technology, for all it's done to improve our lives, is not so apparent. It's refrigeration. The foods we eat, the environments we work in, and the medicines we depend on are all beneficiaries of refrigeration technologies. By the beginning of the last century, the Industrial Revolution had led to the development of many life-improving innovations. Some enterprising inventors were working on the concept of providing cooling from machines. In 1908, those most responsible for the advancement of refrigeration met in Paris for the first meeting of the International Institute of Refrigeration, or IIR.
At the beginning, the IIR was necessary because of the importance of the transport of food. And the preservation of food is still one of the main challenges we have because, as you know, food is necessary for life.
That first meeting began a tradition of international cooperation that has greatly improved our quality of life and allowed us to do things that even those visionaries could not have imagined. Today, scientists and engineers of the IIR come from private industry, academia, and government organizations worldwide. Together, they address issues that affect all facets of life. Through advances in refrigeration and air conditioning, members are helping to improve human health, promote effective food distribution, create more productive workspaces, support a cleaner environment, and counter global warming. The science of food refrigeration affects everyone. In a global marketplace, the goal is to make a variety of foods available everywhere at an affordable price and in a sustainable manner. Members of the IIR are involved in refrigeration applications that range from cold, such as refrigeration, to extreme cold, such as the near absolute zero temperatures needed to explore fundamental particles of matter. They also use refrigeration cycles to pump heat for space conditioning, water heating, and other applications. At universities around the world, ways to improve energy efficiencies throughout the cold chain are being explored.
There's a whole raft of interesting problems with food itself. There's a tendency for people to either look at the food or at the refrigeration, and there's a huge area looking at the interaction between the two, of optimising the food quality and the food safety, but also making the refrigeration system as most efficient as possible.
We look at things like packaging systems for food in the refrigerated cold chain. We look at weight loss from foods. We look at heat and mass transfer when you're processing or storing foods.
Another focus of IIR members is global food transportation.
The research that we're doing for companies is very practical. It's trying to understand how their transport system, alongside their packaging and their product, are interacting as they move product around the globe. One of the areas we've been working with is with the kiwi fruit industry in New Zealand, and are simultaneous design and operation so that they get a better outturn of product quality in the marketplace.
Other IIR members are addressing efficiency in a different way. Climate change is a global problem. Scientists are looking for refrigeration processes that are both efficient and use benign refrigerants, such as carbon dioxide.
I'm doing research on carbon dioxide transcritical cycles in general. More specifically, it's like I'm using carbon dioxide as a working fluid. Then I have some cycle arrangement to make the system work more efficiently and more environmental friendly. I feel that my work is meaningful.
Carbon dioxide systems aren't a new concept, but they are getting a new look by engineers.
CO2 as refrigerant requires development of new components, new systems, new strategies. And of course, the new systems must be equally or more energy efficient than the systems they are going to replace. And that's challenging to manage to get this developed.
IIR members are also working on efficient systems that use a variety of refrigerants, such as fluorocarbons, ammonia, and hydrocarbons.
Natural refrigerants are a possibility to replace CFCs, HCFCs, and HFCs, and all of them have quite a high global warming potential, and all the natural fluids don't have a high global warming potential. Some of them are poisonous, ammonia, or they're flammable, like propane or butane. So if you want to use them in larger systems, you would then have to use indirect systems.
One such indirect system is an ice slurry.
The benefit of using ice slurry is when you want to get the heat from this product, only the ice melts, and then you get the benefit from the latent heat from this mixture, which is much higher than any secondary refrigerant you could use. An ice slurry is a very efficient way of transporting and exchange heat better than any other fluids.
The IIR brings together people who are investigating unique methods of producing refrigeration, such as thermoacoustics, thermoelectric, or thermomagnetic refrigeration.
I'm doing work on magnetic refrigeration. In 2002, we observed that in the field of material science, there were developments of materials which are more performant. These materials also work at room temperature, so this technology can be applied in the usual field of refrigeration technologies for usual wine coolers, refrigerators and other applications.
Others are using laser technology to measure how air flows through coils, so that they can be designed to their maximum effectiveness in air conditioners and heat pumps. Heat pumps can be a very efficient way of taking heat that nature provides in the outside air from water or the ground, and then putting it to use.
Will have a demand to develop new buildings with lower energy demand. So I think it will be important to develop a new generation of heat pumps who can both be used for heating, cooling and hot water production.
Underpinning all this are those scientists who work on the fundamental level, measuring basic thermodynamic and heat transfer properties to extreme accuracy.
Without knowing any accurate knowledge and accurate and extensive knowledge about the different some physical properties of new incoming refrigerant, then people may not be able to design, manufacture, and examine the performances of any products which they are going to produce in the industry.
When fed into a model, engineers can see how these refrigerants behave when mixed, and then estimate how an entire system might operate. Engineers even look at how refrigerants boil. They slow down high-speed video to understand how bubbles form. In doing this, they hope to learn how to increase the heat transfer in systems. This process, fundamental to most refrigeration systems, is still not completely understood. IIR members' work also goes beyond Earth's bounds. Refrigeration helps put humans in orbit and allows us to explore the cosmos beyond. The work being performed by IIR members continues to bring the benefits of refrigeration and air conditioning to more people around the world. The IIR helps this process by promoting knowledge of refrigeration and providing the means for members to share their research with each other. Members present their work at IIR conferences and publish their findings in the acclaimed International Journal of Refrigeration. They also have online access to FreeDoc, the world's most comprehensive refrigeration database. One of the true benefits of membership continues to be the dozens of IIR conferences that are held around the world each year.
One of the main activities of the IIR is the organization of conferences. These are places where scientists and engineers can meet and discuss about new advances in refrigeration technology.
Being associated with the IIR has given me contacts worldwide in the areas in which I have been working, which have been invaluable.
I think the IIR has been fantastic. It's a great advantage to be able to come along to conferences and meet people working within the same area and to discuss problems with them. People are very friendly and helpful.
Yeah, for me, the IIR has provided, I guess, initially a forum, a vehicle for me to take my research and to be able to publish it and present it.
It's the best way I can think of, both of finding out what other people are doing and of publicising what I am doing.
it's a way to build a network. International collaboration will be more and more important in the future, not only for the researcher but also for the industry.
How will membership in IIR help the scientists and engineers of tomorrow?
They need to understand that they're coming into a really vibrant area. This is life and death. This refrigeration area. They've got a great opportunity if they come to be part of the IIR to be part of this network where they can forge their careers and be enthused and guided by some of the other people in this organisation.
Since it began in 1908, the IIR has played an important role in the advancement of refrigeration technologies. No doubt, the founders would be very pleased with what they put in place. May the next 100 years be just as productive. For more information about IIR, visit our website at www.iifir.org.